Hey there, folks! In today's video, I'm excited to walk you through the process of creating a robot, specifically delving into the conceptual framework of its architecture. The journey of modeling and brainstorming for solutions and ideas took roughly 2 weeks. If you're new to 3D modeling and eager to embark on your own creative endeavors, this video aims to delve into the thoughts and ideas that emerged during the creation of this robot. Join me as I share insights from the process. I'm certain you'll find it intriguing, especially considering that I'm not a professional in the 3D field myself, and I've encountered the same challenges and limitations as many of you. All right, let's dive in. Before delving into the modeling process, I want to clarify that I envisioned my robot with the silhouette of a female figure and aimed for a completely humanoid appearance, blurring the lines between machine and character. The process kicks off with the initial blocking out phase, essential for grasping the primary shape, main masses, and desired pose. Here I created basic blocks, considering fundamental anatomical proportions. For instance, I ensured that the head fits approximately 8 times within the length of the figure, and that 4 heads correspond to the length of the legs. It's crucial to pinpoint the center of mass to ensure the figure maintains balance. I strive to depict the model standing confidently on her feet with a graceful posture. This involves spending considerable time studying female figures on Pinterest. I observed that for striking photographs, women often push their chest forward and hips back, resulting in a more pronounced S-shaped curvature of the spine. I'll integrate these observations into my work, with gratitude to the women whose poses inspire these ideas. After the blocking stage, I felt compelled to incorporate a skeleton. Most likely this was done primarily for my own benefit, to understand the placement of bones, major joints, and the volumes of the chest and pelvic bones. In this instance, the skeleton appears highly simplified, with the primary focus remaining on proportions. Given my background in the arts, I find it incredibly valuable to have a basic understanding of skeletal structure. I approach modeling using straightforward geometric shapes, avoiding excessive focus on individual bones. Interestingly, the length of the humerus and forearm bones is roughly equivalent to the length of one head. Moving on, let's tackle the head. While the head boasts a complex shape, it can be constructed from various individual shapes. For instance, the head itself resembles a ball, with its frontal area being more angular and distinct surfaces for the nose and chin. These individual shapes can later facilitate retopology. While sculpting the head in programs like ZBrush or Blender is an option, I prefer conventional polygonal modeling. Working with a different program would necessitate acquiring new skills and habits. Polygonal modeling is advantageous, especially if your aim isn't to replicate a specific person. At this stage, the face might appear somewhat comical and lackluster, but it'll gradually evolve into a more expressive visage. Interestingly, if you're well acquainted with the head's shape and frontal surfaces, modeling can become as easy as 2 plus 2. This brings forth an intriguing observation. If you're passionate about something, modeling it tends to feel smoother and more natural. So try modeling what you love and watch your skills flourish. Moving forward, I wanted to create a plastic representation of the figure using a red material. This step is crucial for establishing a tangible idea of the form. In the future, I'll utilize this shape as a framework within which all the components of the robot will be placed. At this stage, I strive to stick to the basic contours of the female figure. The process feels quite straightforward and relaxed. Even if you make a mistake in proportions, it's easily rectifiable. Additionally, the grid remains as low poly as possible during this phase. Since I already have a skeleton, I essentially overlay it with a mesh. Later, I'll create a separate layer for this mesh and use it as a reference for constructing the entire robot. While it's possible to use a photograph for more precise figure construction, I prefer to rely on my eye for proportions. By the way, I'd love to hear from you in the comments section. What's your background in 3D, and what do you enjoy modeling? I'm always curious to learn which professions seamlessly transition into 3D modeling. Feel free to share the software you use and why. Personally, I started with Blender, but after exploring Maya through tutorials, it became my primary tool. I appreciate its hotkeys, viewport, and the built-in Arnold render. Many other programs offer similar navigation keys. Overall, I'm eager to hear about your software preferences too.
So, I'm diving into the modeling of the main components and assemblies. However, I must confess, I'm not an engineer. My understanding of mechanics is limited. My fascination lies more in the aesthetics of military equipment and how it looks. From what I know, rotors are essential for joint rotation, and hydraulics are crucial for flexion and extension. Creating a minimal environment and lighting is important to render intermediate stages. I don't try to foresee the final outcome too early in the process. Creativity should evolve alongside the creation process. It's normal to add, adjust, and sometimes backtrack to find the right path. At this stage, my focus is primarily on the technical aspects, where the rotors will be placed, how they'll transmit power. It feels like I've become a bit of a modern-day Da Vinci. If he had access to our current technology, we'd probably already be living in harmony with robots under the same roof. By the way, how do you feel about the idea of having a robot roommate? One who shares its problems with you and occasionally asks for money to change its oil and rubber gaskets?
We are not alone. They are among us. As the skies light up, they believe we are blissfully unaware. But this activity by non-human extraterrestrial technology is capturing the attention of humans.
I'm refining the shape of the head, meticulously fitting the shapes together. I aim to make the head part more captivating, adjusting the points to maintain even distances from each other, refining the front surfaces, and delineating the shape of the nose more precisely. If necessary, I tweak the mesh to remove any excess or magnify certain features. It's crucial to eliminate polygons that intrude inward to avoid distorting the shape during smoothing. However, I'll revisit the head and front part multiple times. I want her to possess an appealing face. By the way, if you were to choose a celebrity face for a female robot, whose face would you pick? Share your thoughts in the comments, it'll be entertaining. Personally, I think there's a universal appeal to certain faces. For example, I'd consider attaching Audrey Hepburn's face, along with the hairstyle from the movie Breakfast at Tiffany's. However, I'm eager to hear your opinion as well. Do you happen to know the basic proportions of the head? When viewed from the front, the eyes align with the middle of the head, while the ears align with the eyebrows and the tips of the nose. Additionally, the ears are equidistant from the chin and the tips of the nose, and equal in height to the forehead. Of course, there are more proportions to consider, but I don't want to overwhelm you with technical details. Finally, to bring everything together, I perform retopology on the face mask. Since I don't plan to animate the face, I don't optimize the mesh, I simply aim to make it as uniform as possible. Additionally, I tidy up the lip mesh and refine the grid of eye sockets. Overall, the process is quite technical, and it took me some time, as I encountered several challenges for the first time. Looking back, I realized that many processes could have been completed more efficiently. However, unless you're modeling robots every day, speed isn't always the top priority. I believe it's important to optimize only those processes that are repeated frequently. Now, I'm focusing on creating a space and background for her, ensuring she doesn't appear suspended in empty space. I opted to express her head in an orange hue, a choice influenced by my mood. I wanted to imbue her with a sense of temperament. As I add details, I aim to make the shape more dynamic and engaging. Admittedly, I may have gone overboard in some areas, but this isn't the final iteration. I must confess, I was dissatisfied with how the panels on the front part turned out. Naturally, I removed any that seemed overly complicated or eerie. Moving on to creating the neck area, I incorporate some distinct mechanical elements into it. This allows the head to move relatively freely in relation to the main body, with hydraulic cylinders serving as the equivalent of muscles. Designing the neck structure is quite challenging, as it must facilitate the head's movement with ease and flexibility. When modeling the chest, I had to consider how the arms would pivot and rotate. To achieve rotation movement, I opted to implement electric motors.
I also make it a point to add some materials at this stage to provide a clearer visualization of the mechanisms. For aspiring fashion designers, I'd recommend integrating material selection alongside the modeling process rather than treating it as a separate step. This way, you can ensure that shape, color, material, and lighting work together harmoniously to achieve the desired effect. To construct the spinal column, I opted to create multiple triangle-shaped segments connected by hydraulic cylinders. These cylinders will enable the spine to move, allowing for changes in curvature. While I'm not entirely certain it will function as intended, I'm quite satisfied with how it looks aesthetically. In the chest area, I plan to incorporate a pair of large motor rotors responsible for raising and lowering the arms. To achieve this, I slightly altered the shape of a standard cylinder. As you can see, the modeling process itself is fairly straightforward. The main challenge lies in finding the right design solutions. The motors themselves had to be affixed to a metal frame, all while ensuring that they remain within the confines of the orange silhouette. Towards the lower part, I've essentially duplicated all the components and assemblies. I believe that, from a production standpoint, standardizing all components offers significant advantages. I begin modeling the arms by constructing the main structural masses, which serve as the primary frame for attaching hydraulic cylinders. Many of the ideas are inspired by the T-800 Terminator robot, and you can even discern the internal architecture from it. Observing the current trends in robotics development, I've noticed that electric motors are predominantly used for elbow flexion and extension. However, I personally prefer cylindrical shapes because they're easier to comprehend and more reminiscent of human muscles. Yet, I must acknowledge that a mechanical hand isn't capable of the full range of movements that a human hand can achieve, primarily due to the rigidity of metal. However, this rigidity can also be advantageous, especially when it comes to strength and resilience against external factors like temperature or pressure. The legs are modeled in a manner similar to the arms, with the main difference being the arrangement of the knee joint and ankle joint. These joints bend in different directions. Here, the emphasis lies more on extension rather than bending, as extending the leg often involves lifting the weight of the robot and any additional loads it may carry. Therefore, I place cylinders in the thigh that primarily work to straighten the leg. In the lower leg, hydraulic cylinders located in the calf muscle area are essential for extending the feet, allowing the robot to stand on tiptoes, walk, jump, run, and so forth. My approach to the ankle mechanism closely mimics that of the human ankle, as it's already a well-designed structure. Similarly, the design of the feet is modeled after the human foot, unless the robot is intended to traverse specific terrains like desert sand or snow, in which case adaptations may be necessary. I commenced the final stage of detailing on the head, incorporating panels and covering the geometry from the back, especially since the lips are made of transparent material. At this point, the robot's head already boasts a fairly complete appearance, and further detailing may be unnecessary. Given the robot's open architecture, juxtaposing it with a closed head design can create a visually striking contrast, enhancing its overall appeal. Approaching the neck area, I refine the main design elements and adding supportive loops. If necessary, I adjust the dimensions and shape of the mold to ensure that the neck appears graceful and flexible while adhering to the constraints of the overall design. Given the fascinating design of the human neck, which allows for a wide range of movements, I've started to replicate the main muscles using hydraulic cylinders. The arrangement of wires and hoses mirrors the movement of blood arteries and the nervous system. Interestingly, I've noticed that wires have a remarkable effect on the model, lending it a sense of realism. It seems that our eyes are particularly drawn to wiring, adding to the overall authenticity of the design. As I delve into filling the space within the chest, my focus shifts towards creating a bridge between the motor and the torque shaft. While I'm not an engineer, my aim is to craft an illusion of functionality by strategically placing elements with symbolic significance. Utilizing gears, intricate geometric shapes, and various materials, I strive to evoke the sensation one feels when peering under the hood of a car. I want to convey a sense of sophistication and high-tech ingenuity akin to that experience. Moreover, I'm particularly drawn to the idea of incorporating a diverse range of materials. From plastic to rubber, glass to different metals like aluminum, each part contributes to the overall aesthetic appeal. Some parts may be chrome-plated and shiny, while others appear faded and matte. This variety in materials and textures lends richness and depth to the model. It's crucial to maintain a balance and harmony within the composition. While each individual part may be meticulously modeled, it's essential to consider how they interact with one another as a whole. A well-organized and cohesive composition is visually appealing, whereas discordant elements can disrupt the overall harmony. Ultimately, the key is to prioritize integrity and coherence in the design process, ensuring that every part contributes to the unified aesthetic vision of the robot. It's interesting to observe that in the realm of 3D modeling, many artists tend to focus on the external appearance of robots, often neglecting the intricate structural elements within the joints. However, I've found that delving deeper into the mechanics of robotics engineering presents a more engaging and rewarding challenge than merely decorating the outer casing. Through this process, I've gained a deeper understanding of the challenges faced by robotics engineers and the complexities involved in designing functional and aesthetically pleasing robots. I've come to appreciate that modeling designer cars, robotics, tanks, airplanes, and similar subjects requires a keen eye for detail and a comprehensive understanding of how technology operates. By immersing myself in the study of the external world and the inner workings of technology, I aim to convey a sense of authenticity and realism in my models. I believe that when an artist understands how technology functions, this knowledge is reflected in their work and resonates with the viewer. Furthermore, I've noticed that the most visually appealing technology is often futuristic yet grounded in reality. While fantasy is an integral part of the creative process, it's essential to strike a balance and ensure that the designs remain plausible and relatable to the audience. After all, the allure of technology lies in its potential to transform the future, and by maintaining a sense of realism, we can better envision the possibilities that lie ahead. As I embark on modeling the female breasts, I'm drawn to the idea of crafting rounded coolers. This concept appeals to me as coolers typically boast a visually pleasing appearance. I particularly enjoy incorporating elements such as fans, renowned for their sleek and elegant shapes. Similarly, jet engines, with their fans and fairings, also offer a visually striking aesthetic. Simultaneously, I further intricate the design by integrating wiring. Leveraging curves and the mesh sweep tool, I weave a network of wires and embed them within the structure. In the region of the hip bones, specialized shields or screens are modeled to safeguard the internal space with ample rigidity. Given the feminine silhouette, the side elements will be generously spaced. Typically, I gravitate towards modeling with a military theme, and it's likely that this robot will also adopt a military specialty. Generally, the sooner robots are integrated into military operations, the sooner humans will be displaced. Human infantry in warfare pose significant logistical challenges. They require training, support, and ongoing care. Introducing military robots offers clear advantages. They don't succumb to oil loss but can simply be repaired. The only significant threat they face is fire, yet even in such environments, they remain operational, often outperforming humans. The benefits are undeniable. All that's left is to accelerate technological progress. Robots indeed have the potential to excel in various roles, from pilots and sailors to astronauts, snipers, sappers, drone operators, artillerymen, drivers, machine gunners, attack aircraft, doctors, and beyond. The possibilities are endless, limited only by our imagination. This raises the question, what should people do? Perhaps focus on aspects such as relationships, recreation, sports, exploration of spirituality, scientific research, and more. Returning to the modeling process, I've addressed the main challenges and gained a solid understanding of design principles. Now, the focus is on refining and detailing every aspect, bringing specificity to the model. This involves adding parts, selecting materials, incorporating wiring, and so forth. I've come to realize the importance of mechanical elements such as panels, bolts, rivets, and various small details in achieving photorealism. These details breathe life into the model, giving it the tangible feel of a material object. Even though crafting micro details may require more time, they are essential for creating a sense of authenticity. As the saying goes, the devil is in the details.
The fire makes the city look so bright. Close your eyes and just stay tight. We have to go. Stay with me while we leave. Don't worry, just believe me. This journey will relieve us. Stay with me while we leave. Stay with me while we leave. Don't worry, just believe me. This journey will relieve us. Stay with me. Stay with me while we leave. Don't worry, just believe me. This journey will relieve us. Stay with me while we leave. Stay with me while we leave. Don't worry, just believe me. This journey will relieve us. Stay with me while we leave.
Friends, that wraps up everything I wanted to share about robot modeling. I hope you found it engaging and insightful. Thank you for joining me on this journey. Wishing you all great success in your own 3D modeling endeavors. Don't hesitate to leave your comments and feedback. I look forward to seeing you again soon, and in the next video, I'll share more exciting tales from my 3D adventure. Until then, take care and goodbye.